Okay, we're going to do an overview of all the questions that involve convergence and divergence and ratios or intervals of a convergence and uh, radius of convergence. So this gets kind of combined. Next week will be Taylor series polynomials. Um, so here's the overview. First question, and by the way, pause before you start, before you do anything. Try it yourself and then see what I do. First thing I do with series is I will expand them out and just see what they're like, because if I can see that the terms are decreasing, I automatically know it will diverge. So, and then usually I can disprove it by the nth test. But first thing I'm going to write this out, and I plug in 1, I get 2 over 1 factorial. And then I plus 3 over 2 factorial plus 4 over 3 factorial plus dot dot dot. And I got the idea what the series looks like. That's 2 plus 3 over 2 times 1, which is what 2 factorial means. 2 times 1 is 2, plus 4 over 3 factorial is 3 times 2 times 1, which is 6, plus, and I can see right now that the terms do get smaller. It goes from 2 to 1.5 to 2/3, so it's decreasing. So I can't conclude anything, but certainly I know that I can't automatically conclude that it diverges. So the next thing I probably want to do is do an nth test and then check to see if it's geometric. While I have this written out, let's just check to see if it's geometric. If it's geometric, there has to be a constant ratio between each term. So if I take 3 over 2 and divide by 2, I get 3/4. If I take 4/6 or 2/3 and divide by the term in front of it, 3/2, I get, flip it over, I get 4/9. These are not the same, so it's not geometric. So now I'm going to try the nth test real quick, and just to see, because nth test can tell me if it diverges. If it does, the limit as n approaches infinity does not equal 0, I don't have any conclusion. Or I'm sorry, if it equals 0, there's no conclusion. But if it's something besides 0, I can conclude it diverges. So limit as n approaches infinity of the a sub n term. This is the a sub n term. So I'm going to take I'm sorry, you probably didn't see that. This is the nth term. So I'm going to take the limit as n approaches infinity, and I get infinity plus 1, or infinity, over infinity factorial. That means infinity times infinity subtract 1 times infinity subtract 2, all the way down to 1. I mean, that's infinity. So in L'Hopital's rule applies. Of course, you would write that on an FRQ. And then limit as n approaches infinity, take the derivative of the top, gives me 1. Derivative of the n plus 1 is 1 over the derivative of n factorial. I really am not sure what that is. Okay, but if I take the derivative of that, I'm going to get some kind of infinity. So now my derivative of that, I get 1 over n, which is 0. That's inconclusive. You can't, equal 0 is inconclusive. Anything besides 0 would give me divergent. So I've already exhausted the nth test and the geometric tests. So perhaps I'm not really sure what to do with this nth term here. So what I'm going to do is I'm going to just try ratio test. Ratio test would be, take the limit as n approaches infinity. Just so you know what I'm looking for. I'm looking for that. I'm going to take the limit as n approaches infinity of the n plus 1 term divided by a sub n, and that's going to be my limit. And if that limit is less than 0, it converges. If it's less than 1, it converges. If it is greater than 1, it diverges. If it equals to 1 is the only thing that I don't want, which means it's inconclusive. So let's test this out here real quick. So I'm going to take I'm going to take this term, the a sub n term, and I'm going to add 1. So wherever I see an n, I'm going to plug in n plus 1. So n plus 1 over n plus 1 factorial. Now I'm going to divide by the a sub n term. But instead of dividing by this fraction, I'm going to multiply by the reciprocal, which is n factorial over n plus 1. I just reciprocated it. Now, to make this my life a little easier, I'm going to put my factorials together and my parts together. In other words, I'm seeing this is a factorial part, this is a factorial part. The other two pieces here are not. So I'm going to kind of combine them. I'm going to write the n plus 2 over the n plus 1 times, now I'm going to put my factorial parts together, n factorial over n plus 1 factorial. This piece here, now remember we can take the limit of each part separately, so I'm going to take the limit of this piece and the limit of this piece separately and see what I get. The limit of this gives me infinity over infinity. L'Hopital's rule applies, which gives me 1 over 1 is 1. So far that part's completely eliminated. I'm now only worried about 1. Now the other part is factorialed. Now let's see if I can reduce this factorial stuff. Now remember, n factorial means n times the next number below it, which is n minus 1, times the number below that, which is this, times all the way down to 1. All over n plus 1 times n minus 1, n minus 2, all the way down to 1. So I just basically expanded those two factorials because n factorial is this and n plus 1 factorial is n plus 1 factorial times n all the way down. But notice that I can reduce this because the n's cancel, n minus 1 cancels, n minus 2 cancels, and all terms after that will cancel, leaving me with the limit as n approaches infinity of 1 over n plus 1, which equals 0. Reminder that if the limit I get from the ratio test is less than 1, it will converge. So I have concluded, since L is less than 0, therefore converges. And I'm done with that part, that one. Next question is this one. I looked at it and I already get kind of warm and fuzzy because I see that the n's are in the exponent. I'm hoping it's geometric. Let's write this out and see what we get. Plug in 1. I get 2 over 5 square. I'm going to leave 5 square so I can see it better. And that's actually 2 to the 1. Equals, or plus, 2, plug in 2, 5 to the third, plus 2 to the third over 5 to the fourth, plus ... I'm already kind of warm and fuzzy because I can see right now that each term is multiplied by 2/5. Multiplied by 2/5. Since this is a constant ratio, I know it's geometric. It's geometric with the following. First term is 2 to the 1. My first term is right here. My first term is 2 over 25 with an r of 2/5. So to answer the question, does it converge? It converges because it's geometric with r that falls between those two numbers. 2/5 falls in between. Okay, so it's definitely convergent. Not only that, because it's geometric, I also know since it converges, I also know what it converges to. It converges to the function a sub 1 over 1 minus r, which in this case is a sub 1 is 2 over 25 divided by 1 minus 2/5. So 2 over 25 times 5/5 take away 2/5 is 3/5. Flip it over, 5/3 reduces to, I believe, and I could be lying, 2 over 15. So not only do I know it converges, I know it converges to the value of 2 over 15. That's example number 2. Pause. Again, pause. So you get a chance to try it yourself. And now, again, okay, you paused. I'm going to write it out. This part right here kind of gives me a clue. I'm already seeing that it's going to alternate from a positive to negative. So I'm going to think to myself, hey, this is probably going to be alternating series. Alternating series requires three things. I need the limit as the a sub n term approaches infinity needs to go to 0. I need to see the values decreasing, and it has to be alternating from positive to negative. So kind of 3 things in order for it to pass an the alternate series test. So I'm going to write it out first. Now this might take me a minute because this is not easy. So I plug it in. I get -1 over 1 squared plus 1 is 2. So it becomes times 2 over, plug in 1. I get 2 plus 1 is 3. Subtract this 2. So right now I have -1 plus. Next term is 2. Give me a minute, I'm cheating. I'm using my calculator because I'm not that intelligent. I'm actually what I'm doing, so you can see, is I'm typing in, that bottom is going to be a pain in the butt. So what I do is I typed it out, I wrote this denominator out, and then I'm going to look at my table, and that's going to help me plug in values real quick and easy. So using those values, I can do the bottom relatively quickly. So the next thing is I'm going to plug in 2, and if you plug in 2, you get +1 times 2 squared is 4 plus 1 is 5 over, now I'm cheating, I'm looking at the calculator, and I get a 9 plus, do the next term, I'm going to get 3 terms to kind of get a feel for this. Plug in 3, I get -1 times 3 squared plus 1 is 10 over, now I'm cheating, I'm looking at my calculator and I see 3 plugged in is, gee, I can't see it, 20. So this plus ... and so let's go ahead and look at what I have. I've got -1 plus 5/9 minus 1/2 plus, okay, so the first thing I do is I say, okay, 1. Did it alternate? Yes. It changes from positive to negative. 2. Are these values decreasing? Well, 1 is less than 5, the absolute value of them. 1 goes to 5/9, which is smaller. which is smaller, and 1/2 is smaller than that. So yes, it's decreasing. 3. Now I have to conclude that the limit as n approaches infinity of the a sub n term has to equal 0 in order for me to conclude that in fact this converges. So I'm going to take the limit of this puppy, the a sub n term. Limit as n approaches infinity of the a sub n term. What is the a sub n term? That's this thing. You've got n squared plus 1 over 2n squared plus n minus 1. Now if I plug in infinity, I'm seeing infinity or infinity. L'Hopital's rule applies. I also can consider lead terms, which is a condensed version of L'Hopital's rule. If I look at that right there, the lead terms are n squared over 2n squared, which means this is equals to 1/2, which does not equal 0, and I'm just about ready to cry. Well, since it doesn't equal to 0, I'm going to have to conclude. Since it did not pass all three, I was getting so excited. I was like, oh my gosh, this has got to converge. It's alternating. It was decreasing. So check, check, check. This did not apply. Therefore, by alternating series test, we have divergent. Again, I was getting all warm and fuzzy because you can't shortcut this thing. But basically, I plugged it in, saw the values decreased. I saw that it's alternating, so I'm kind of hoping that this thing converges, but in fact it does not, because the limit as n approaches infinity of the a sub n term I found to be 1/2, which does not equal 0. Therefore, by the alternating series test, it will diverge. Next one. Woo! Okay, let's check this one out here. First thing I'm going to do is I'm going to write it out, just because. Easy to conclude it diverges as the values increase. Equals 1 over the square root of, I think I'm going to cheat again. I'm going to use my calculator. I'm going to type in n subtract or plus 1 plus 2. Look at my table, and again I can look at the table and kind of conclude values underneath there. So my first one is 6. Could have done that, but I prefer when I get to the more difficult ones I could just plug them in. So then I'm going to plug in 2, and I get 1 over square root of, from my calculator, 24 plus 1 over square root of 60 plus dot dot dot. Okay, I can see that the values are definitely decreasing. That's a good thing. You can check the derivative test or the geometric series, but if you check it out, the ratios do not comply. Just to show you, 1 over square root of 24 divided by the previous term, which is the reciprocal, multiplied by reciprocal, gives me 1 over square root of 4. If I take 1 over square root of 60 times, or divide by the previous term, or multiply by reciprocal, I get this, square root of 24, which is going to be less fun than I thought. Let's see, square root of 4 over square root of 10, which is 2 over square root of 10. It doesn't really matter. I can see that these two things are not the same, therefore it's not geometric, so I can't use that. Now I'm going to take the nth test. the nth test can kind of reveal something that's a function similar that compares to this function, but it's not exactly the same. See these plus ones and plus twos, these pieces? When we're going off to infinity, they really are irrelevant. They're insignificant. So if I take the nth test, which means I take the limit as n approaches infinity of the a sub n term, if I get this to not equal 0, then I can conclude that it diverges. However, if I take the limit of this as approaches infinity, I get 1 over infinity, which is 0. So my nth test is inconclusive. So I'm going to proceed now to say, well, dang it, these silly, stupid plus ones and plus two things, are they significant? Can I compare this to some other function? Okay, I'm going to try to compare. The a sub n term is this one. If I ignore the plus 1 and the plus 2 here, then I conclude that's about the same thing as square root of n to the third, or 1 over n to the 3/2 power. Okay, now what I'm looking for is, I'm looking at this guy. I mean, I'm kind of excited because, see, if I can conclude that this guy diverges, then I'm in good shape. This guy right here is a p-series. And my p is equal to 3/2. The p-series says that if p is greater than 1, which it is, it will converge. So I can conclude that this guy right here converges. Now, that would be my comparison function, my Cn. This is my An. Now, again, graphically, and hopefully you can see this spot right over here. Hopefully I have a Cn. Since it converges, I'm hoping that the An is below it because it's trapped into the convergency range, which is anything below this. So I'm hoping that this is less than. Let's consider this. I'm adding stuff to the bottom. If I add stuff to the bottom, it makes the bottom bigger, which makes the whole thing smaller. That means I can conclude that, in fact, my Cn is bigger than my An. So by direct comparison, since I already have my work shown here, I can say that the a sub n is less than Cn, and Cn converges by p-series test. And therefore